Welcome back to Summarize Science. What if an AI could learn to understand the health of our oceans just by looking at pictures from space? A new paper outlines a powerful foundation model that aims to do just that. Studying the ocean is incredibly hard, it's vast, and getting direct measurements is expensive and time-consuming. This means we have very little labeled data, which is the fuel traditional AI models need to learn. This paper's goal was to build an AI that could work effectively with the small amounts of high-quality data we do have. To do this, they used a huge amount of unlabeled data from the Sentinel-3 satellite, covering the entire globe. They fed these images to a vision transformer AI, a model architecture that is great at understanding patterns in images. The training process was clever. They showed the AI images with random patches blacked out and tasked it with filling in the blanks. By doing this millions of times, the AI learned the fundamental patterns and rules of what the ocean surface looks like from space, without ever being told what it was looking at. With this pre-trained foundation model ready, they tested it on two specific tasks. First, they wanted to see if it could accurately measure chlorophyll concentration, which is a key indicator of phytoplankton, or algae, in the water. To test this, they compared their foundation model against a model trained from scratch, meaning one that didn't have the benefit of pre-training. And the results for mapping chlorophyll were fascinating. While the raw error scores were similar, the visual output told a completely different story. The model trained from scratch produced a blurry, generalized map of chlorophyll in the North Sea. But the foundation model, shown here in panel C, created a much more detailed and realistic map that closely matched the established satellite product in panel D. The second test was even more challenging, estimating ocean primary production, which is essentially how much carbon dioxide phytoplankton pull from the atmosphere. This is a critical process for understanding global climate change, but the data for it is even more scarce. They repeated the experiment, but this time also tested how the models performed with even smaller amounts of training data. Here, the foundation model's advantage was undeniable. This chart shows the error rate as more training data is used. The yellow line, representing the foundation model, shows that it starts learning effectively and improves significantly with just 25% of the already tiny dataset, which was only 19 data points. The Scratch model, in teal, struggled to learn much at all with so little information. So, let's recap the important takeaways. This new foundation model approach allows an AI to learn the fundamental patterns of the ocean from vast, unlabeled satellite data. This pre-training gives it a massive head start, enabling it to create detailed, realistic spatial maps that other models can't. Most importantly, it demonstrates an incredible ability to learn complex tasks from extremely small amounts of labeled data. This data-efficient approach is a potential game-changer for ocean science, where data is a precious resource. In the future, models like this could give us more robust and nuanced insights into our changing oceans, helping us better monitor everything from harmful algal blooms to the ocean's role in the global climate.